Hello, I am Edeltraud Aspoeck from the Austrian Academy of Sciences and the Institute for Oriental and European Archaeology, and together with Gerald Hiebel from the University of Innsbruck, Institute for Geoinformatics, we are going to talk about the Puzzle-in-4D project. The Puzzle-in-4D project is about the digital preservation of resources from a long-term excavation project that was carried out in Egypt. And it started during Ariadne 1, and what was influenced by Ariadne by the way we took to data integration. And so that's going to be one focus of the talk today, and another focus is going to be the technology stack, which was something that was suggestion by the review of the abstract of this for this talk, and the technology stack is actually something that is done by our colleagues at the Austrian Center for Digital Humanities, but we have been briefly updated, and I'll do my best to inform you on that. Yes, so this is going to be the content of this talk. So I'm going to first introduce you into the project, the archaeological site, then Gerald will talk about data integration, and then I'll talk about the system architecture and the workflow we have. Yeah, so the el-Daba archaeological site, it's a site in the Eastern Nile Delta, and it has actually quite a long occupation cycle. It's mainly early Bronze Age. And the site is famous because it has many connections to parts of the Mediterranean. So, and very famous are these wall paintings, which are nearly identical to those which are found in Minoan and Crete. And it has been excavated since 1966 by Austrian archaeologists Margaret Bittag and Irene Forster-Müller. And since 1966, as you can imagine, a huge amount of resources have accumulated. So thousands of photos, all sorts of written documentation. And so it's not that we wanted to tackle all of these resources and digitize them in this project, because that would be possible, but there's some of the resources started deteriorating, like some photo negatives. So they started changing through time, and so the aim was to preserve all them. So that's, here's just an example of documentation we are dealing with. And then we also have a huge amount of digital documentation. And so, because in this time, of course, there was a change from analog to digital, and so whilst the method of documentation was carried on in the digital period, there hasn't been really a data management plan. And so, been file naming and also ordering of files has been done according to many different criteria. So either fieldwork season, person who worked on it, fantasy names. So it's really, so that poses a whole set of new problems. And sorry. Yeah, so the challenges of the problem of the project were, of course, also the huge amount of resources, and but also to create a data model and the metadata that would make it possible to find the resources, make them also reuse, make it possible to use them, and find a way to integrate the metadata, and then also to develop a workflow for digitizing, creating data, ingesting them in the repository, and ingesting them in the repository and publishing them. Yeah, so
Thank you very much. For the data integration, you must imagine we have all these resources, and we started with the analog resources, and we tried to find out how to integrate them, how to relate one document to the other, and what are the units we are relating them to. And this was influenced by the Ariadne approach, of course, and we took the site of CRM as the underlying schema, and thought what are the concepts there that we can use that are represented in our documentation. So we chose the CRM with the CM-Archaeo extension, and we chose semantic technologies for the data integration process. Because there are quite some complex relations, I want to show it in a little bit later. But first we asked ourselves what are the questions that we want to answer with our data model, with our data. And for example, we have all these analog documents like the plans, like the reports. And for example, we want to know what of a specific excavation area, which documents cover this excavation area, or which archaeological features or find types are present at this excavation area. For example, for some grave number 5 in this case, in a specific excavation area, what are the finds found there in this grave? And also the specific types of finds like amphora or these things. And the model we finally chose was that one. So we said there's an excavation area, and this excavation area contains archaeological features and finds. And these two things represent the fundamental differences here, represented here in Archaeo of the excavation unit. This is what happens at excavation time, and the stratigraphic units, what happened in archaeological times and the times that we are researching on. And this differentiation is also expressed in the analog documentation, like for you have your excavation areas, they're called like F1, or then in the areas down under the aerial, it's the E21 for example, and then you have the different planums because the methodology of excavation was the planum excavation, so you took off like 20 centimeters or 50 centimeters, then you documented that and took off another 50 centimeters. And then the archaeological finds were recorded in a specific structure too. All of these two things, they are documented in the documentation, which is the analog documentation, and later on it was digital documentation, databases or AutoCAD plans. They are stored in a physical storage, and this documentation was, for example, digitized or further elaborated, further researched on, and created a digital secondary documentation. And the analog documentation has a very straight line of documentation. It's very clear how the things are referenced to. The identifiers are very clear, so that helped us to reference the things together found in the different documents. For example, here we have. I wanted to give them an example of these archaeological features and finds. The locus, this comes out in the locus database, and or the finds, and they are referenced in the analog documentation, but as well in the digital documentation with the same identifiers. And this is something which is essential for making this integration of data. Okay.
Yes, so yes, for the technology, we actually first revised some of the ready-made systems, but then we decided to develop something on our own, and with open and well-defined interfaces, which so that the components can be replaced based on the principle that the data is the most important thing. And so we have 3 components, which is, so we distinguish between the data creation, the curation, and then the data integration and the archiving, and then finally the dissemination part. And I'm going to show you the overview of the whole thing at the end, and first talk about the different stages. So data creation, which means digitizing resources, but also transforming digital resources to durable file formats happens at the Institute Aurea, or at the Aurea Institute, by a team of 4 to 5 students. And for the metadata creation, we are actually sticking to Excel, which developed this way that we started with Microsoft Excel, just when we were experimenting how to do it, but then realized that it's actually a really fast way, of course, of data entering, and which, if you have to deal with large numbers of resources, then it's actually really quick. So we stuck to that. And so, of course, this has advantages, but then also disadvantages, because we don't have the control that a database would offer. And I think, yeah, so now we are going to find out of how many mistakes there are and how this whole thing works. And yeah, but there's different versions of the metadata in a, so there's a control of the version by a Git repository. Then yeah, what Gerald talked about, so the data integration is done via Karma, so the Excel sheets then go into map to the Sidoc CRM, and then the Karma tool exports RDF, and which is then stored in the triple store where the data is integrated. And sorry. And then another important part of this, of our system architecture, is Archaeology. That's the repository of the Austrian Academy of Sciences, which is a repository for the humanities, and it's quite new, so it hasn't existed actually when we started the project. This is based on Fedora 4, sorry, and yeah, they have their own custom metadata scheme on a project collection at file level, which we are using. Yeah, then the third part, so the main access to the digital archive will be via our homepage, where you can find a lot of the documentation of the project, and also, so this is the prototype of the front end, where you can see yeah, the metadata that we have created, and then also you can look at digital resources and also download them. And so that's the final workflow. So to the left is our data creation. As I said, it's done via Excel sheets, and then so for the time being, everything is stored at the network share, and then the actual the data actually goes from there to we are about to start the ingest into Archaeology, the repository, and then with the metadata. So our original idea, and that's what we were presenting so far, is that to do all the data integration in the triple store, but then we were actually struggling here, which is where the user can actually access the metadata in the triple store. So so now it's kind of the plan that we adopt MetaFactory. Or this has actually been adopted by our colleagues at the ACDH for the Parthenos project. But because we were, there was this problem in how that not all users can do Sparky. So we also have an addition. So our main way to actually access the resources will be via a PostgreSQL database, so the spreadsheets also go there, and so the main way for the user will be via this web application, and and that will also be so the metadata and the resources then come via Triple server from Archaeology directly. Yeah. So that's 2 or 3 ways into, and then there's another way also to go, of course, to directly search the archive for the resources. Yeah. So the project runs until beginning of next year, and we will now do the ingest, do the documentation, and also finalize the web application. Thank you.